Have you ever looked up at the night sky and wondered about the unseen forces shaping the universe? While the stars shine brightly, there's an invisible presence weaving the cosmos together, a mystery so profound it challenges everything we think we know. Dark matter, the enigmatic substance that makes up most of the universe's mass, is a puzzle that has stumped scientists for decades. And here's the kicker, we've never even seen it. Sounds impossible, right? How can something we can't detect or touch be so essential? It's like trying to explain the existence of air to someone who's never felt the wind. But here's the truth, without dark matter, galaxies wouldn't exist, the stars wouldn't be where they are, and life as we know it wouldn't have a stage to unfold. The stakes couldn't be higher, and the quest to understand this cosmic ghost is one of humanity's most thrilling adventures. So, if you've ever wondered what lies beyond the visible, get ready to dive into a story that's stranger than fiction. The evidence is out there, the clues are piling up, and the greatest minds of our time are racing to crack the code. Are you ready to uncover the mystery of dark matter? Why is dark matter invisible? Imagine trying to see the wind, not the dust it stirs up or the leaves it carries, but the air itself. Dark matter is a similar enigma. It doesn't emit light, reflect it, or even absorb it. Scientists have likened it to a ghost drifting through the cosmos, indifferent to the forces that make ordinary matter visible. If you shine a flashlight in a dark room, the beam reveals everything in its path. But with dark matter, the flashlight might as well not exist, it slips past undetected, leaving no trace. This invisibility is rooted in its nature. Dark matter doesn't interact with electromagnetic forces, the same forces that let us see, touch, or even heat objects. Think about a magician's invisible thread, it's there, holding everything together, but you can't see it. Similarly, dark matter silently holds galaxies in place, weaving the universe's grand tapestry. For scientists, this means relying on indirect clues to sense its presence, a bit like Sherlock Holmes piecing together a mystery from shadows and whispers. And yet, it's not just invisibility that makes dark matter fascinating. Its elusiveness is what fuels countless experiments and sleepless nights in observatories and labs. It's the detective story of our era, a puzzle of cosmic proportions waiting to be solved. But if you thought invisibility was its only trick, wait until you see how it dances through galaxies, leaving behind undeniable evidence of its existence. When astronomers first observed galaxies spinning, they expected to see the outer stars moving slower, much like planets in our solar system orbiting farther from the sun. But instead, those outer stars zipped along at unexpected speeds, defying the gravitational pull of visible matter. It was as if an invisible hand was gripping these galaxies, preventing them from flying apart. This curious motion was one of the first undeniable pieces of evidence pointing to dark matter's existence. Take the Milky Way, for instance. Our galaxy's edges spin as though cradled by an enormous, unseen mass. If only the visible stars, gas, and dust contributed to its gravity, the edges would simply unravel. Instead, something hidden, something far greater in mass, holds it all together. Scientists have measured this hidden weight using gravitational lensing, where light bends around massive objects. It's like seeing a funhouse mirror in space, revealing an invisible yet influential presence. These galactic mysteries are more than mere curiosities, they're clues. Just as fingerprints at a crime scene point to the culprit, these gravitational behaviors highlight dark matter's role in cosmic architecture. But if we're building the case, the next question becomes, how do we catch something so elusive? The hunt, as you'll see, demands extraordinary ingenuity. Detecting dark matter is like trying to hear a whisper in a stadium full of roaring fans. It requires patience, precision, and ingenuity. Scientists have devised experiments deep underground, shielded from cosmic rays and other distractions. These detectors, often filled with ultrapure substances like xenon, are designed to catch the faintest interactions between dark matter and ordinary particles. Imagine a fishing net in a vast ocean, waiting to snag an elusive creature no one has ever seen. Then there's the hunt in the skies. Astronomers use telescopes to look for gamma rays or high-energy particles that might be byproducts of dark matter annihilation. It's as if they're scanning the universe for smoke signals, subtle traces that betray its presence. One example is the Fermi Gamma Ray Space Telescope, which has been scouring the cosmos for years, piecing together the story hidden in these celestial clues. The search isn't just about catching dark matter in the act, it's about understanding its nature. Some scientists are even smashing particles together in massive colliders like CERN's Large Hadron Collider, hoping to recreate conditions from the Big Bang when dark matter might have first emerged. Each experiment is a testament to human curiosity and determination, bringing us closer to unraveling the mystery. And what about the suspects? Let's dive into the possible particles behind the phenomenon. When it comes to dark matter, scientists are essentially profiling suspects. Two of the top contenders are WIMPs, weakly interacting massive particles, and axions. WIMPs are the heavyweights, hypothetical particles that could explain dark matter's gravitational effects. Picture them as cosmic introverts, massive enough to influence galaxies, but so aloof they rarely interact with ordinary matter. If WIMPs exist, they might occasionally bump into atoms, and this rare interaction is exactly what experiments like those underground detectors are designed to capture. Axions, on the other hand, are the featherweights. These tiny, hypothetical particles are theorized to be incredibly light, yet present in enormous numbers. Imagine the universe blanketed in a sea of axions, each one as subtle as a whisper. They might be responsible for certain peculiarities in the behavior of light and electromagnetic fields, prompting scientists to use supersensitive devices like resonant cavities to listen for their presence, almost like tuning into a radio station broadcast from the depths of space. Both WIMPs and axions hold tantalizing promise, but they're not the only suspects. Other theories propose particles like sterile neutrinos or even entirely new forces of nature. The possibilities are as vast as the cosmos itself. And while the search continues, it raises a profound question: why does dark matter play such a crucial role in shaping the universe's structure? Dark matter is often called the cosmic scaffolding because it shapes the very structure of the universe. Without it, galaxies as we know them might never have formed. In the early universe, dark matter's gravitational pull acted as a cosmic glue, gathering ordinary matter into dense regions where stars and galaxies could take shape. Imagine pouring grains of sand onto an invisible framework. Dark matter provided that framework, giving structure to an otherwise chaotic cosmos. Even today, its influence persists. The large-scale distribution of galaxies follows patterns dictated by dark matter. Clusters of galaxies, those colossal gatherings of stars, owe their existence to its steady, unseen hand. Without dark matter, these clusters would simply fall apart. Simulations of the universe's evolution repeatedly confirm this. Take out dark matter, and everything unravels. It's like removing the foundation of a building. Nothing else can hold the structure in place. But dark matter's role isn't just about keeping things together, it also shapes how we understand the universe's future. The balance between dark matter, dark energy, and ordinary matter determines whether the cosmos will expand forever or collapse in on itself. It's the ultimate cosmic chess game, with dark matter as one of the key players. And as the mystery deepens, it leaves us pondering the next steps in uncovering its secrets. The universe is vast, mysterious, and brimming with secrets waiting to be uncovered, and dark matter is perhaps the greatest enigma of them all. But what will you do with this newfound understanding? Will you let it spark your curiosity, leading you to dig deeper into the mysteries of the cosmos? Or perhaps you'll see the parallels in your own life, realizing how often the invisible forces shape what we perceive as reality. Have you ever stopped to think about what unseen forces guide your decisions, relationships, or even your dreams? Just as dark matter binds the universe, perhaps there are invisible elements holding your world together too. What steps will you take to explore these hidden influences? Leave a comment below and let's unravel these mysteries together. And if this journey into the cosmos inspired you, don't let it stop here. Subscribe to the channel, hit the notification bell, and stay tuned for more explorations into the unknown. Together, we'll continue to uncover the secrets of our universe, one mystery at a time.